Last question of this paper is question number 10. This question is from complex numbers. The polynomial x cube plus 5x square plus 31x plus 75 is denoted by px. Part A of this question, show that x plus 3 is a factor of px. X plus 3 is a factor of px. This part is related to factor and remainder theorem. Px is equal to polynomial in x is equal to x cube plus 5x square plus 31 x plus 75. Since x plus 3 is a factor of this polynomial, so remainder will be 0. So we have to show that remainder is equal to 0. The method to find the remainder, x plus 3, from here value of x will be minus 3. So we are putting x plus 3 is equal to 0. From here x is equal to negative 3. This is the way to find a remainder. Now we are putting here in place of x we will put minus 3. On the right hand side numbers must be equal to 0 because x plus 3 is a factor of px. Putting the value of x is equal to minus 3. Here we get minus 3 cube plus 5 into minus 3 square plus 31 minus 3 plus 75. We get minus 27 plus 45 minus 93 plus 75. After calculating, we get this is equal to 0. Equal to 0. This shows that x plus 3 is a factor of polynomial because the remainder is equal to 0. This is the way to find the remainder. Now part B of this question is show that z is equal to minus 1 plus 2 under root 6 iota is a root of pz is equal to 0. We have to show that z is equal to minus 1 plus 2 under root 6 iota is a root of pz is equal to 0. Now we have pz. Now in this question we will replace x by z because this is px. Now pz will be we replace x by z. So we can write that polynomial in z is equal to z cube plus 5z square plus 31z plus 75. We have to show that minus 1 plus 2 under root 6 iota is a root of this polynomial. So we will put this value of z in this polynomial and we have to get 0. The result should be 0. This shows that minus 1 plus 2 under root 6 iota is the root of pz is equal to 0. Now z is equal to minus 1 plus 2 under root 6 iota we are putting here. We are finding Pz. Z is equal to minus 1 plus 2 under root 6 iota. Putting here we get minus 1 plus 2 under root 6 iota power 3 plus 5 into minus 1 plus 2 under root 6 iota square plus 31 minus 1 plus 2 under root 6 iota plus 75. Now we will simplify all these terms. Now we will expand this because the power is 3. We can write it in terms of 2 factors minus 1 plus 2 under root 6 iota square into minus 1 plus 2 under root 6 iota. Next is 5 into minus 1 plus 2 under root 6 iota square plus 31 into minus 1 plus 2 under root 6 iota plus 75. Now we will use identity here, and also here we use the identity a plus b whole square, a square plus b square plus 2ab, because there is negative sign, so we a minus b whole square, a square plus b square minus 2ab. We will use this identity in this term and in this term. So using the identity we get minus 1 minus 24. A square is minus 1 square is 1, and square of 2 under root 6 iota, 2 under root 6 iota will become 4 into 6 into iota square. Iota square is negative 1, so we get minus 24. We are writing here 1 minus 24 minus 2ab means 4 under root 6 iota. We have expanded this using identity. It will remain same. Minus 1 plus 2 under root 6 iota. Next is 5. Again we are using the identity. Same will be here. 1 minus 24 minus 4 under root 6 iota. Now for next term we will multiply 31 by both terms inside the bracket. We get minus 31 plus 62 under root 6 iota plus 75. Further simplification, we get minus 23 minus 4 under root 6 iota into minus 1 plus 2 under root 6 iota plus 5 minus 23 minus 4 under root 6 iota minus 31 plus 62 under root 6 iota plus 75. Further simplifying, we will multiply these factors. This will become minus multiplying these two factors, we get 23 minus 46 under root 6 iota plus 4 under root 6 iota plus 48 minus 115 multiplying 5 y minus 23, we get minus 115 minus 20 under root 6 iota minus 31 plus 62 under root 6 iota plus 75. Now all these terms will be cancelled out. All these terms will be cancelled. So finally we get 0. This shows that 0 shows because polynomial z is equal to 0. So this shows that minus 1 plus 2 under root 6 iota is a root of polynomial z is equal to 0. The next part C of this question is part C. Hence find the complex numbers z which are roots of polynomial in z square is equal to 0. We have to find z which z shows the complex numbers. Now here probability polynomial of z square, not z but z square is equal to 0. Pz is given. This is a cubic polynomial which has three roots. Because the maximum power of the variable is 3, there are three roots of pz. Now this implies that when we will take square of z, we get polynomial with highest power 6. When we will take the square of this, the maximum power of z will be z6. This shows that we have 6 roots. So now in the first question, in the first part, x plus 3 is a factor of px. We can show that if we replace x by z, we can say that z plus 3 is a factor of pz. Z plus 3 is a factor of pz. Polynomial pz is equal to z cube plus 5z square plus 31z plus 75. When pz is equal to 0, there are three roots of this. Clearly, z plus 3 is equal to 0 from here. Z is equal to minus 3. This is the root of z. This is a real root. Z is equal to minus 3. This is a real root because the total roots of this polynomial are 3 in numbers. So other two roots will be in conjugate form. One root is given, that is minus 1 plus 2 under root 6 iota. The other root will be its conjugate. So one root is z is equal to minus 3. Other two roots will be z is equal to minus 1 plus 2 under root 6 iota and z is equal to conjugate of this complex number. Other root will be minus 1 minus 2 under root 6 iota. We change the sign of imaginary part. We get the conjugate minus these are the conjugate to each other. So there are three roots: z is equal to minus 3, z is equal to this, and z is equal to this. These are three roots of pz is equal to 0. Now pz in this question, pz square is equal to 0. So this shows that now pz square is equal to 0. This shows that first we write this z is equal to minus 3 means z square is equal to minus 3. Z square is equal to minus 3. Taking square root each side, we get z is equal to plus minus 3 under root iota. This shows that there are two roots. Z, we will say z1 positive under root 3 iota, and z2 is equal to minus under root 3 iota. These are two roots of pz square. Total roots will be 6 because the maximum power of pz square will be z6. So just we have found only two roots, remaining four roots. Now we will take the square root of uh, this complex number. Then we get two roots from here, two roots from here. Total roots will be 6. Now we will take the square root of this. So for this, let minus 1 square root of minus 1 plus 2 minus 1 plus 6, 2 under root 6 iota. We have to find the square root of this. Let the square root of this complex number is also a complex number. Let this that complex number is x plus iota y. From this equation, we will find the value of x and y. We get the complex number. Now taking square each side, we get minus 1 plus 2 under root 6 iota square of right side x plus iota y whole square. We will expand this. We get x a square plus b square plus 2ab x square plus iota y square. Iota y whole square mean iota square y square. Iota square is negative 1, so minus y square we get from here. So x square minus y square plus 2xy iota. Now comparing the real and imaginary parts from here. Real parts on the left hand side is minus 1. Real part on the right hand side is x square minus 1. X square minus y square. So equating we get minus 1 is equal to x square minus y square, and equating imaginary parts 2xy on the left hand side 2 under root 6. We get 2 under root 6 is equal to 2xy. Dividing each side by 2, we get under root 6 is equal to xy. From here, we are making y the subject. Y is equal to under root 6 over x. Now we will solve these two equations. this equation and this equation we are solving by substitution method. We will find two values of x and two values of y. We are solving these two equations, putting the value of y here, we get minus 1 is equal to x square minus y square. Y is 6 under root over x whole square. Simplifying, further simplifying, we get x4 plus x square minus 6 is equal to 0. Now we will find from here, this is a disguised quadratic equation because x square and x4, 2 is a 2 time, 4 is a 2 time of 2. So we can use a process of solving disguised quadratic equation. Let x square is equal to u. Now this equation become u square plus u minus 6 is equal to 0. Factorizing, we get u square plus 3u minus 2u minus 6 is equal to 0. These are the factors. U minus 2 into u plus 3 is equal to 0. From here we get two values of u. U is equal to 2 and u is equal to negative 3. Now actually u is x square. So resubstituting, we get x square is equal to 2. From here, taking square root each side, we get x is equal to plus minus under root 2. So this is these are two values of x, but we cannot put here x square because we cannot put here. This is not applicable. This is not applicable. Why this is not applicable? Because if we are putting uh, in place of u x square, then x square is equal to negative 3, x is equal to we cannot take it x is equal to, we can, when we will take square root we get plus minus under root 3 iota, but we have supposed here in the start of the question x is a real part. X is a real part, y is an imaginary part, so from here we cannot have a real number on the right hand side, because on the right hand side in the term involving iota, so this is not applicable. So only the answer is plus minus x is equal to plus minus under root 2. This is not applicable. Now we will find the values of y. Putting here the value of x, we get two values of y. From here, putting the value of x, we get two values of y. So y is equal to 6 under root over plus minus 2 under root. So we get cancel out under root 3 plus minus under root 3, we get y is equal to plus minus under root 3. So complex numbers are z1 z2 we have found already. Two complex numbers we have already found. Two complex number will be from here two values of x and two values of y. This shows that Z3, we say Z3, third complex number will be 2 under root plus putting the value of x and y here, 2 under root plus 3 under root iota, and Z4 will be minus 2 under root minus under root 3 iota. So just we have found four complex numbers. Now we will take also the square root of this conjugate of this z. In the same way we will find two roots from here. We will take square root of this complex number in the same way. So same process, minus 1 minus 2 under root 6 iota square root, let this is equal to x plus iota y. Scaling each side we get minus 1 minus 2 under root 6. Square root sign will be removed. On the right hand side we will use identity, a square plus b square plus 2ab. This becomes x square plus iota y whole square, that again will become minus y square because iota square is equal to negative 1. So x square minus y square plus 2xy iota. Comparing real and imaginary parts, we get minus 1 is equal to x square minus y square, and minus 2 under root 6 is equal to 2xy. Dividing by 2 each side, we get minus 6 under root is equal to xy. From here y is equal to minus 6 under root over x. Now we will solve these two equations simultaneously by using a substitution method. We will find two values of x and two values of y. So minus 1 is equal to x square minus y square. The value of y is this. So minus x square minus 6 under root over x whole square. Simplifying we get minus 1 is equal to x square minus 6 over x square. Further simplifying we get x4 plus x square minus 6 is equal to 0. Again this is a disguised quadratic equation. We will solve this disguised quadratic equation by taking a suitable substitution. Let x square is equal to u, then this equation will become a u square plus u minus 6 is equal to 0. Again we solve this to find two values of u, factorizing u square plus 3u minus 2u minus 6 is equal to 0. U into u plus 3 minus 2 into u plus 3 is equal to 0. U minus 2, u plus 3 is equal to 0 from here. U is equal to 2, u is equal to negative 3, which is not applicable. So only we have the value of u is equal to 2. Now resubstitute कर दें. X square is equal to u means x square is equal to u is the substitution. Putting here x square, we get x square is equal to 2. Taking square root, we get x is equal to plus minus under root 2. Now putting this value of x here in this equation, we get two values of y. Here is our, this step is tricky. Y is equal to minus 6 under root over x. Now putting this value of x, since x is equal to plus minus, so we get y is equal to minus 6 under root over plus minus 2 under root. This will be cancelled out. Under root 6 under root 2 we get under root 3, but this negative sign will make this plus minus minus plus, because plus minus is multiplied by minus 1, so we get minus plus. This plus minus, due to this negative sign, will become negative positive. So we get two values of y. This is very important. So we get two values of y. Y is equal to negative plus under root 3. So this shows that with the positive value of x, we get the value of y negative. So we get z5. Putting here the value of x and y, because we have supposed this square root of this is equal to x plus iota y. We have found two values of x and two values of y. So z5 fifth root is equal to 2 under root plus, this is the positive value of x, and with this value of y will be negative. 2 under root minus under root 3 iota. This is a complex number, and z6 will be minus 2 under root plus under root 3. With this negative value of x, there will be positive value of y. We get minus 2 under root plus under root 3 iota. This is a sixth complex number.